In this next set of problems, we are going to learn how to write chemical reactions from actually words. Let's look at the first problem. Phosphorus trichloride liquid. This tells us that I have phosphorus. My first element in this compound is phosphorus. So I write a P. Trichloride. The tri is telling me that there's 3 chlorines. Chloride tells me that there's Cl, and the tri tells me there's 3. And it says it's liquid, so I put an L in parentheses by the 3. Plus, I'm adding silver fluoride solid. It tells me that there's silver, there's my silver, and fluoride solid. Now I have to pause and I have to make sure that this molecule is actually neutral. Fluorine has a -1 charge always because it's group 7. Silver is a transition metal, but it's one of those exceptions that it always has a +1 charge. The way I have it written, therefore, is a neutral compound because I have a +1 and a -1 gives me an overall charge of 0. This is my second reactant. It produces phosphorus trifluoride gas. Once again, phosphorus is my first P. Trifluoride, that means that I have fluoride as an anion, or actually as a second atom, and I have 3 because it's trifluoride, and it's gas. Tells me that it's in the gaseous form, plus silver chloride solid. Once again, I write my silver, and then I write my chloride, and then I put an S over here. I have to make sure, because this is an ionic compound, a metal and a nonmetal, this is covalent and so is this, but these two are ionic. I have to make sure that I have a neutral compound. Chloride will always have a -1 charge because it's in the same group with fluorine. It's a group 7. They always have a -1 charge. Silver doesn't change. It has a +1 charge. Therefore, that's a neutral molecule. And now I can take a look and see if I have this reaction balanced. I do not, because I have 3 chlorines over here, only 1 over here. I have 3 fluorides over here, but only 1 over here. Therefore, to balance my fluorine out, I can put a 3 in front of silver fluoride here. But now I changed my silver, I made a 3, and therefore I can put a 3 in front of that molecule. 3 silvers, 3 silvers, 3 chlorines, 3 chlorines, 1 phosphorus, 1 phosphorus, and I'm balanced. Remember, when you are writing the formula of a compound for ionic compound, you have to make sure that that compound is written in a neutral way, which means the total positive charge has to equal the total negative charge. For those, you have to know the charges of the polyatomic ions. You have to know the charges by group. So group 1 always has a +1 charge. Group 2 elements in the periodic table have a +2 charge. Then you have the halides, which are group 7. They always have a -1 charge. Group 6 always has a 2- charge. Group 5, nitrogen and phosphorus, they have a 3- charge, etc., etc. So remember the charges and the names, because otherwise you will not be able to balance to actually write neutral compounds. When we're writing neutral compounds, we do manipulate the subscripts because we're writing the compound. When we're balancing whole reactions, we never mess with the subscripts. We manipulate the coefficients in front of the molecule. Big distinction there. Let's look at the next problem. Copper 2 chloride. I know that I have copper and I know that I have chlorine. It tells me that is copper 2 in parentheses Roman numeral. What that means is that my copper is a transition element, And because it is a transition element, transition metal, it can have more than one charge. It can form an ion with more than one charge. That 2 in the parentheses tells me that it is copper 2+. So the Roman numeral tells you the charge on the metal. Copper 2 tells me that there is a 2+ charge on the copper. Chlorine is a group 7. Group 7 ions are always -1, always. Therefore, chlorine will always be -1. Now, as I've written it, this isn't a neutral compound because I have an excess of positive charge. I have 2+ and a -1. To make this a neutral compound, I need to make the positive charge equal to the negative charge. To do that, I need 2 chlorines. That each chlorine has a -1 charge, but 2 of them give me a total of 2-. I cannot put, once again, I'm writing the chemical formula. I do not mess with the molar coefficients in this case. I mess with the subscripts when I'm writing a neutral compound. That will be what I put down. So I put down a 2 here by the chloride. Now this is a neutral compound because I have a 2+ -1 times 2 gives me a 2-. This is actually a neutral compound. And it tells me that they are aqueous solutions. So this is an aqueous solution. And it mixes with silver nitrate aqueous solution. Silver, as we said earlier here, is a +1. And nitrate is NO3. It's a polyatomic ion, and the charge on it is a -1. Think of that -1 being over this whole unit. If I were to replace that by an X, for example, it'd be X to the -1. So NO3 has, the whole unit NO3 has a -1 charge. Not just the oxygen, not just the nitrogen. When you have polyatomic ions, treat them as one unit. This is neutral the way it's written, so I don't need to make any changes. I mix these and it tells me that I form silver chloride solid. Silver chloride. Silver is a +1. Chloride is a -1. Therefore, the way it's written, it's neutral. And it tells me that it's a solid compound. Plus copper 2 nitrate. Copper 2 tells me that it's 2+. Copper is 2+. Nitrate, NO3, is still -1. Okay, these charges have not changed. I just flipped partners, if you will. I flipped positive and negative ions. Therefore, I need to make sure that this is a neutral compound. So now I do mess with the subscript. I have 2 here, a -1 here. Now that -1 charge is over the whole unit, what's in parentheses. To make this a neutral compound, I need 2 NO3 units. One has a -1, I need another -1 to make a -2. And therefore, I put a subscript of 2 right by the NO3. I don't put it in front. That is for balancing whole chemical reactions. To make a neutral compound, I mess with subscripts. And now I have got neutral compounds here. I have to take a look and see, am I balanced here? I have 2 chlorines and I have 1 over here. Therefore, I need to put a 2 in front of my silver chloride, which changes my silver over here. I have 2 silvers and 2 nitrates, but I have only 1 here. And if I put a 2 in front of the whole molecule now, because I'm balancing the whole chemical reaction, I am balanced. I have 2 silvers, 2 nitrates, 2 of the whole unit, 2 nitrates, 2 of the whole unit, 2 nitrates. I'm balanced. Okay, I will erase this and then we will continue with the next set of problems, which is more of writing chemical reactions from actual words.